Hi. Okay, it's time for one of the videos I've been putting off a little bit. I've had these PCBs for a little while now, but I wanted to get to that first execution point before I distracted myself. But it's time to do some soldering. So this tiny little power management chip is the first piece of surface mount soldering I ever did, and there's quite a few devices on here. So by no means take anything that happens from this point forward as the correct way to do anything. I think Dave Jones at EEV Blog has a good series on soldering, which I thoroughly recommend. It's what I had a quick revise on. But this might give you an idea of what to expect when you first try it. So let's talk about how these are going to work. I've got a strip board here. Now my plan is all the different parts of the processor are going to be done as small little modules like this, and then I'll make up a larger PCB backplane to plug them all together. But as I'm going, I need temporary connections between them to make everything work. So this is one of the reasons why I put all of these common bus lines in a row, because then I can use a piece of strip board like this as a temporary backplane. So I've soldered a couple of female pin headers on here, and I've got some males to connect up here and make those connections. And then for these control lines over here, I've made up these shorter little versions of it. So in theory that should connect up like that, and I'll have access to all the control lines and the bus lines. So I've set my soldering iron to 370 degrees centigrade. I've got my talisman against oxidization, and I've got my surface mount components. So I'm going to clean the board down a little bit, and the pins. Now this is actually a lens cleaning cloth, but it's basically alcohol based, so it's not that dissimilar to the base of the flux. And my thinking also is if I get these pins in first, then they should provide a bit of stable support for the board while I do the rest of the work. One of the big bits of advice seems to be flux is never a bad thing. Let's see how this goes. Okay, that seems good. It's also, I soldered all these connections into the backplane, and these have got big chunks of copper and no solder mask, and it's definitely a lot harder to do that. Not the neatest solder joints in the world, but I think they're electrically good. These are plated holes, so it's actually the solder is getting wicked inside the hole, and that should hopefully be providing a very good connection without me needing a great big heap of solder on the outside. I'm going to try a different solder for a minute here, because I'm not really happy with how this stuff's responding. Okay, these new ones are quite a lot shinier than the old ones. Sorry, this solder. This stuff was cheap off eBay, but it's slightly finer. I'm expecting this first board to be a little bit of a sacrificial one. I did get spares and spare components, but let's see how these connections are looking. So there was a ground pin over here, and I believe that one there is ground. That's a good sign. Now I'm dropping the temperature to 320. Let's take a look at these surface mount components. Now I have learnt from experience surface mount components, when I've taken a few out just to have a look at, But if you put them anywhere and turn your back on them, they will disappear. It's definitely not me knocking them off with my sleeve or anything like that. See, these ones are doing a runner already. Might be easier to do it like that. Okay, so what is the prescribed way of turning over an SMD component? Let's try straight ones. That works. I believe the thing to do here is to get a blob of solder onto the pads. So I'm not really giving any of my own wisdom here, but the masters on YouTube say you put a blob of solder on and then you move the component into it so it gets well anchored. Okay, you can all laugh, but left-handed tweezer manipulation was not something I was ever practiced on. Okay, that almost looks half decent. Let's do all the others before we turn the board over. So these are just the current limiting resistors. These are actually higher value. I think they're about 2.5K. I can't read the number. I was umming and ahhing a bit because I like to underdrive the LEDs a little bit, just to avoid high current drain on the board. I don't suppose it actually matters which way up these are. Okay, if anyone out there knows the reliably good way of turning these things over, okay, it may just be practice. In theory, the other side should be easier. What with not needing to cringe while you watch me try and manipulate the things into place with the tweezers. It's almost like it's soldered before I bring any solder in. It's like the remains of the solder from the previous joint is what's actually immediately wicking in. Okay, this solder is definitely producing much shinier joints than the other stuff. I may go back over all of those once I'm done. Let's try for some LEDs. I believe the green bit, the side the green is on, goes towards positive. Okay, so I'm going to try and test these LEDs before I stick 16 of them in the wrong way around. This point here should give me ground. Hey, success. 7 solder joints that had to work in order for that to the LED to come on. Okay, I think I already fluxed that, but wisdom definitely seems to be that you can't have too much. Okay, I may have been slightly over aggressive on the resistors for this. They're a bit dim. I'll have to double check what size I actually bought. Sponge isn't anything like as good as it feels like it should be for wiping excess solder off. See if I can get one of those copper wire wool type things that I've seen other people use. Okay, let's give that a try. Okay. It's embarrassingly bad. Okay, I have worked out a way of removing these, although what I need to do is get some desolder wick. But if I switch to this longer tip, I can, and then I put an extra bead of solder on. Okay, if you learn anything from this video, it's seriously double check your LEDs are going on the right way around. Okay, so I've changed my tip back. Hope it goes okay this time. I've got new LEDs. Not quite sure how this is going to work. Now this whole learning experience definitely says one thing. I will never not check the LED polarity. Success. I definitely blew one of these original LEDs up because I connected it without a resistor in series, but I've replaced them all because I've got no idea what my faffing about desoldering did to them. And the other thing is, these LEDs are on the signal lines and they are active low. So the common here is actually VCC. So it's important to make sure that these ones are actually the opposite way around. Tell me I got that one wrong. Okay, there's one that doesn't work. Let's double check those connections. Alright, slightly dodgy connection there. Despite all the mistakes, I appear to have a fully functional set of LEDs. Let's look at the other passives. Anything left are the capacitors. Okay, learning number 2. Don't cut off a single one of these things. Do the first side on all of these. Now these smaller ones are 100 nanofarad. I can't actually remember what the value is on the larger one. It was quite a bit bigger. My understanding's correct. These small ones are decoupling high frequency drain on the power rail right up close to the chip, and then the larger one is just balancing out the power consumption of the board a little bit. as we learnt with the LEDs, it is much easier to correct any alignment issues when there's only one terminal soldered. Okay, there's probably nothing left to do but do the bit I've been desperately avoiding. Okay, these things are tiny. Okay, they definitely seem to have a tiny little circle in this top right hand corner, which is actually because I turn these around 180 degrees for the wiring. That means that is pin 1, I assume. Alright, well, this is going to be tough. So the recommended technique on these appears to be get the corners done and then come back and drag the other sides. Definitely bridge those connections. You'll probably call me an idiot for attempting this before my solder wick arrived, but let's see if I can't clean that up a little bit here. Let's load. That was ground, that's decrement, and that's increment. And these are all active high. Well, that's not working. Alright, I'm going to stop the video here so I can use my camera up close to zoom in and see if I can work out what's going on. Success! Okay, sorry, that was a little bit of a quick debug on the side, but it was actually all okay, but I had very foolishly not connected up the clear line, which was permanently resetting the HCT193 counter here. So now we've got the first of the counter chips in, and it is counting from 0 to 15 in binary. So that is very, very promising, but I've got 3 more of those to do. Now, here's something to point out. You've seen me build an awful lot of circuit boards on the breadboard, and I've not disconnected power while I'm working on it. But when we're soldering, my understanding is that's very, very necessary, especially with the USB device I'm using for power, because it's isolated from the mains. So while the ground and VCC, or the 5-volt rail, have hopefully exactly 5 volts between them, between that and the mains earth there could be quite a large voltage, so we don't ever want to expose the circuitry to that. Now, if I ever plug these things in the wrong way, we will be, or solder these things in the wrong way, we'll be taking a break while I order a heat gun. I'm going to put a different wire in this clear line, just to remind me that it needs to go low and not high. Okay, it appears you definitely want to avoid getting too much solder on the soldering iron. It does tend to accumulate on there. Okay, that fifth pin down on the right doesn't look good. Active low. This decrement needs to be high. Load needs to be high. I keep calling the increment and decrement active low, but they're not. They're active high, but they need to be kept high, so it's the actor bringing it low and returning it again. So it's very easy to get into the habit of thinking about it in those terms. And now we wait to see how high it can count. So that's about to roll over into the third nibble. Good. Can wish I've set the maximum speed on this thing a bit higher now. I believe if I take this capacitor out, then it will actually just count really, really fast. Yes. Okay, so that tells us the counting lines are at least soldered correctly. I can't tell you much about the inputs for loading, but we can give that a try in a little while. But I need to take a little break and have my lunch now, and also get this phone I'm using as a camera on charge, because it's started to complain at me. Okay, so we've got just the 4 D-type latch chips to go in now. Okay, so these ones actually do have a notch in them where we'd expect. Pin pitch on these is actually exactly the same as these ones, but the larger size makes them a little bit less scary. I think on this one I've misaligned it very slightly, so there's less than normal solder mask between each of the pins, which is making it very difficult. Okay, this is where desolder wick would come in very, very handy. Okay, nothing about this is pretty, but I think it's all there. Now I do need to go and bring the extra lines we've got here high. So these are the 2 assert lines. That's the reset line. The clock. That's the increment line, but we can do whatever we want with it. So these are assert lines, and they're active low again. And I also need this one, which is the clock line that is used by the latches to pull the current value in. So a good indicator that this is not completely messed up will be this continuing to work, which it's not. Always found power to be handy. Power the correct way around even more so. Okay, that's weird. Yeah, that's acting like we've got a short somewhere. Oh, word. This one here is the wrong way round. I can't believe I made that mistake. And as you can see, it's working inside the processor. Now, there's an awful lot of learnings from this. I need to be a lot more careful on which way round to put stuff. I had to turn this chip around, which was extremely painful, and by turn it around I mean destroy it in the removal process and solder a new one on. But you know, the counter register is actually working. It's currently acting as our program counter, so I feel pretty good about that. Now, the soldering is far from perfect, but this was literally the first bit of surface mount soldering I did with any quantity. That was the only thing I had done before, and so the fact that I've designed a circuit, designed a PCB, soldered it up and had it actually work is more than anything else proof that anyone can do this. I can see from here there's a couple of the capacitors where I forgot to solder the second half on, but this is very much going to be a sacrificial board. I think a second one of these I'll be able to do an awful lot better on, but I don't think I'll be videoing that. I'll just get that done. Now, we can't really experiment with some of the more interesting stuff involving the address registers until we've got more than one, so I will be soldering up a few more of these. It's a total of 5 we need, but there's a few things I want to get. I'm going to see if I can find another reel of solder. I need some better magnification. I need some PCB cleaner because my standard alcohol wipes are not cutting through this flux.